Here we have an iPhone 7 that came in for data recovery. Customer wrote in the title of the ticket, iPhone 7 data recovery. Nobody mails over an iPhone 7 or an older phone for the sake of fixing that phone. How much is an iPhone 7 right now? You can go to eBay and buy one for $70, $80 maybe, or even less. I don't know how much they are going for. So anytime we get an older phone, whether it's an iPhone 5, iPhone 6, iPhone 7, iPhone 8, even iPhone X, it means it came in for data recovery. We got a flip phone about a week ago, and that flip phone, if you go to eBay to buy one, it's about $20 if somebody wants to buy it. It's an ancient vintage phone. It came in because that customer had information. We did fix the motherboard for the customer, and then it turned out that that phone had 2 pictures only. And the customer said that phone had 2 pictures. If that phone had 2 pictures or 1,000 pictures, the job is done. It's not my problem. We do not charge you for how many photos are on that phone. We fixed the motherboard. We were able to turn the phone on. If you had 2 photos or 6 million photos, it's going to be the same price, a data recovery price. So right now we already have the motherboard out, and Big Boss, as an initial inspection, he removed the shield, the black shield from here, and the black shield from here. And of course he marked the ticket number on that motherboard in case. We do not want to mix motherboards for customers, so we always have the ticket number on the phone itself, like this, and we have the ticket number on the motherboard or on the charger or on the case or on the bag, whatever the case may be. Customers, they like to send everything over, so we always have labels for every little thing that customers mail over. Let's take a look at the board and see what's going on. Just a quick visual inspection. I have not worked on this phone before recording the video. Anytime I work on any device, everything is done in real time. I do not previously know what's wrong with that device. If I do, I mention it. Whether I worked on it before or did not work on it before, it's an educational video. You're going to learn something by watching the video. Even if I do not fix any devices when making a video, there's something to learn from every video. Whether it's life lessons or philosophy or repairs or whatever the case may be, there's always something to learn from every video. I do not post useless videos. So the board overall looks very clean. No signs of corrosion, no signs of liquid damage. And what is that scratch doing here, right? What is it doing here? Did you previously work on this phone? Let me just do quick measurements while we are visually inspecting the board. That way we can hit 2 birds with 1 stone. So if we go to diode mode, and do we have a short circuit on VCC main? That's VCC main right here. And we do not have a short on VCC main. And just randomly measure some capacitors. We do not have a short. Just random measurements for now. We do not have a short anywhere. And just based on visual inspection, this guy is a bit discolored. A discolored component does not mean the component is bad. I mean, look at this component. It looks a bit yellowish. This one looks white. It does not mean that this component is bad or both components are bad. But this one here looks kind of corroded. That may be nothing. If we measure here, and look at this, at that short. So we're going to have a that short everywhere because all those caps are connecting in parallel. I mean, every cap has a that short, every single cap. Few minutes in and we already got it. Wow. I do not want to get too excited, but if it quacks like a duck, it walks like a duck, it's probably a duck. That's the way I think of it. It's not going to rain if it's not cloudy, right? You do not see rain with blue skies. So I'm done with this side of the board and we're done with the front side of the board. Right now we're going to be using an iPhone power supply and it looks something like this. I mentioned this tool in previous videos. It's an iPhone power tool. We can supply battery power and charging cable power via this tool. I'll show you how it works. This tool is sold on our site. You can log in to NorthridgeFix.com, add to cart, along with all the other tools that you need. Everything from soldering stations, hot air stations, this amazing microscope, and now we have the new version, the red color, articulating arm, the ring light, anti-glare light, which we currently have out of stock, the awesome braid wick that we sell, solder sucker, the short, NF short, charging stations, tweezers, original, Amtech Flux, everything is sold on our site and all items are in stock. Just add to cart, check out, pay, and we almost always ship out same day. Let me show you how this tool works. We need to supply power to this tool in order to use it. We can supply power in multiple ways. We can plug in a power adapter ranging from 3 volts to 28 volts. Any power adapter that you have, whether it's a 5 volts, 12 volts, 23 volts, whatever the case may be, you can plug it here. Even a laptop adapter, 19 volts, you can plug it here. Or you can power this device using a micro USB cable, or you can plug those banana plugs onto your power supply and set voltage to 5 volts, and this device will work. So you have multiple options for power. Let's say your micro USB connector went bad, we can still power this device on using the banana plugs plugged into your power supply, or we can use a power adapter right here. Multiple ways to power this device. In my case, I'm going to use a micro USB cable right here, and I'm going to plug it right there. So now this device is on. Then what we have to do is we have to look at the cables. Which one is iPhone 7? This one is 7, 4.7, yes. So this one is 7, and this one is 7 Plus. And inside the box, you have cables for every iPhone from version 6 all the way up to, I believe, 13 Pro Max. We have the details on our site. But for now, we're going to plug that cable onto the motherboard. So this cable connects your battery. We're going to supply battery power and a charging cable power. Okay? 2 in 1. Let me show it to you under the microscope. If you have not used that tool before or similar tools, let me show you how it works. You see? We have the battery connector right here, and we have the charging connector right here. So we connected both as one piece. Battery connector and the charging connector. Let me unplug, you see? If we flip the cable, right there. So that's for iPhone 7. iPhone 7 Plus has a different cable. For example, this one here, that's 7 Plus, 5.5 inch is 7 Plus. The connector is a bit different. You see? Anyway, now a healthy working board, when we press on the power button on this device, we should see amp draw starting at 0.3 amps, 0.4 amps, 0.6 amps. It goes above 1 amp, and then it settles down to about 0.3, 0.4 amps. That's a healthy motherboard. Right now, if I press on the power button, it tries to start, and then it goes back to 0. I press, it picks up just for a split second, and then it goes off. You see? Let me take you under the microscope. Maybe you can see that better. Look, if I press on the power button, the camera is not in focus, but it doesn't matter. You see, it tries to start, and then it goes back to 0. So we have an issue. We have an issue with the motherboard, and that's why the customer mailed this board over or the phone over, because the motherboard has an issue. So where should we look? What I want to do is grab my thermal camera, and I want to monitor the board under a thermal camera while we press on that button and see what happens. Now, I did not apply any power yet. You do see some yellow spots here and there, and that's reflection. That's nothing to do with heat. You have to be able to differentiate between a heat spot and reflections. If I tilt my camera, we get rid of the reflections, you see? All right, so let's try to press on that button and see what happens in that split second. Look at this. Look at this. Wow. Clear as daylight. Look at this. And where is heat coming from? I need to be able to pinpoint where heat is coming from. Right there. Right there. Let me go under the microscope. And I believe that's right next to the component I told you does not look good. I have my tweezer pointed here. Of course, I cannot be 100% accurate when I point my tweezer. But if I pointed my tweezer here, it's very likely that this component is bad, because that's the only one that looks really bad. And I believe, I mean, even without a thermal camera or anything, I would have started with this component, since we have a short circuit at that short in this area. Now, one problem with this area is components are very tight. If we apply hot air and solder liquefies all across this area and we try to remove this component, we may end up shifting, by mistake, shifting all those components in this area. Maybe I try to remove this component while solder is liquefied and my hand shakes a bit, and I'm going to end up knocking a lot of components off their position. So what is the best way to deal with this scenario? We're going to rip this component out. We're not going to apply hot air. We're just going to aggressively rip that component off the board. Right? Aggressively. Because we're trying to recover data from this phone. So we have to be aggressive. Just like that. Just rip the guts out. Right? Done. Am I recording? Yes. The question is, will that solve the problem? I do not know. We're going to have to check. I could have used an atomizer, applied some flux powder, and hit that button, but heat is being generated fraction of a second. So I do not know if that will work, if flux powder will work. Alcohol will most definitely not work. We were able to see heat using a thermal camera, but I do not think there's any other way to know which component is bad other than the thermal camera for this scenario, because heat is being generated for a split second. What do you think? I'm afraid to try it. That's too exciting. Too exciting. Do we still have a short circuit? We can measure. One thing we can do is measure, and the other thing we can do is push that power button and see if it's going to go to 0 again in a split second. That's what we can do. Should we try it? 1, 2, and yes. Done. Wow. You see, it's not going off. And I have it backwards. It should be like this. Right now we are at 0.1 amps. All right. We're done. What about replacing that cap? We're not going to replace that cap. That's for sure. I do not want to disturb other caps in the area, and that cap is not needed. I talked about this in countless number of videos on YouTube. If you have 100 security guards guarding a building, and one of them called in sick, I cannot make it today, we still have 99 security guards guarding that building. Nothing is going to change. Everything is going to work perfect. So one guy out, we still have a lot more guarding that building. We have this guy, this guy, this guy, this guy. How many? We have a lot. And the reason they put in a lot of caps is because if they wanted to combine the value with one cap, that cap will be super big. So in order to spread the value on that board, they divide that value into too many smaller caps to make up that one big value. All of them are connected in parallel. Now you know why a motherboard contains a lot of capacitors. If we measure here, I'm getting a short because that's ground. And if we measure on the other side, we probably have low resistance. Look at this, 0.02 voltage drop It's no longer 0. If we go to resistance mode, a beep in diode mode does not always mean it's a short. You have to know if it's a dead short or if there's any value to that capacitor. In this case, we are now reading 0.02. If we go to resistance mode and we measure here, we are measuring 19 ohms. Perfect. So we do not have a dead short anymore. So what does that all mean? It means we're going to have to plug the phone inside the housing and try it. If we talk the talk, we have to walk the walk, right? Right now, I'm doing Big Boss's job because he already left home. He called it off for the day. We got a lot of packing supplies today. I mean, a lot. And Big Boss and my dad worked all day to organize the boxes, shipping supplies, and all that stuff. Screen goes first, and battery goes last. Okay, screen is connected. The charging connector is connected, and now we're going to connect the battery. And we're going to attempt to power that phone on, assuming the battery is charged. And I got nothing on the screen. Nothing at all. What does that mean? It means we either have a dead battery or the battery is not plugged in properly, or the screen is not plugged in properly. One of the three. Or the screen is faulty. One of the four. I do have a charging cable right here, so let's try it that way. And I think it's me. Oh, right there. I do see the battery logo right here. And the phone is charging at 5.2 volts at 1.7 amps. Awesome. See? Look. The camera will probably not focus here unless I put my face here. And I'm not going to put my face here. Or maybe I should. Like this. Okay, 5 volts at 1.7 amps. Perfect. We fixed that phone and we located the bad guy. So say hello to the bad guy. He's already gone. Threw him in the trash. I'll pause the video for 5 minutes and I'll be back. All right, good news. A few minutes later, the phone is on. Wow, we did it. We did it. That's it. Last repair for the day. I hope you enjoyed this video. Let me know what you think. Leave it down in the comments. Don't forget to like and subscribe, and we'll do something else in the next video. And right now it's 5:30. I'm done. I fixed a lot of devices today, and I'm done.